Okay. All right, man. So the pattern here is times 2 each time. Times 2, times 2, times 2. So when it's multiplied, or what's the reverse of multiplication? Divide. When it's a pattern of multiplication or division, that's a geometric sequence. I should say or division. I should say a pattern of constant multiplication of decision. So it's multiplied or divided by the same number each time. Because you could technically have like it times 3, then times 2, 10 times 3, 10 times 2. That would not be geometric.
Good morning, Mr. Tobal.
Good morning, man.
How's your night?
My night is good.
Yeah, I'm so tired.
I feel you. No, this is completely new. Last time we did arithmetic sequences, which was patterns of adding and subtracting.
So, you guys think it took me so long, so many steps.
Yeah,
Like 3 pages I sent you.
I'll check it out. Because I usually just check it out like after the test.
Each problem is like a paragraph.
For those?
Yeah. They're short, like 5 problems.
Yeah, they take a while, I guess. But either way, this one, oh, yeah, last time we did adding and subtracting patterns, this is multiplication or division. So that's what's different, which means it's just a different equation and different things. The concepts are actually very similar. It's just that your equation is a little different, that's all. As you guys write, the equation is going to be an equals, just like the previous one is an equals. What was the last equation? A1, just make sure you said that, plus D and minus 1, yeah. So that was the previous one, that's for arithmetic, so that's a pattern that's adding or subtracting. Right now, no, because there's only like 4 formulas, so I think you can know that. We're gonna say no for now, and if I change my mind, it's for the better. I don't want to I don't want to say yes and then change my mind no. So I gotta say no and then change my mind. Yeah, as of right now, no. Okay. What are we looking at? Okay, so the equation for this is going to be A1 times R to the power n minus 1. So this is an exponent n minus 1.
A1 plus R?
Times R. Now, a lot of these are the same. The AN is the same, the A1 is the same, the N is the same. The only difference is the R, the D, which is now an R. So the R represents the ratio, but for us, or how we always refer to it, is the pattern. This is the pattern. So the R is the ratio. The A1, the AN, the N is the same thing. So the only thing is that these equations uses R for ratio, while the adding or subtracting uses D for difference, aka the patterns. So let's take this equation and turn it into, or let's take this pattern and turn it into the equation. 3 is my
A1, sorry.
A1. AN is going to stay a variable. So 3 is my first term. So that's going to be my A1. Good. And then times, I'm just going to explain it for everybody. So times 2, because my pattern is the 2. To the power of n minus 1. So 3 is because it's my first term, and then 2 is because that's my pattern. Go ahead. And it's what step you are. So then I could follow up. You have your equation, let's say. Please give me what A of, where we got 5, 6, 7. Let's do A of 7 is. Okay. So A of 7, we're going to follow this formula. 3 times 2 to the power of 7 minus 1. So we take the 7 and plug it in for the n.
Wait, why are you taking 3 and 2? You're using the same numbers from before? Like
I'm using the same numbers. This will be one question. This will be a separate question. It's the question I gave you. So I would tell you, give me A7. So they would be separate questions, obviously. Or if they're the same question, it'll be part A, part B. And then we'll do the math. So 2 to the 6th power, this is what I really want to know. Yes, you have to do the power first, exponent first. Do not do 3 times 2 first to get 6, then do the power of 6. That will be incorrect. So make sure, power first. Because that's a common error I see. So 48, 2 to the 6th power is 48. No, wait. No, it's not. 2 times 2 times 2 is 8. And then 8 times 8 is 64. This is 64. 64 times 3. And then 64 times 3, 2 carry the 1, 192. Which means the A7, or the 7th term in this pattern, would be 192. Okay. Haley, you got it down? Okay. So let's do, I'll give you 2 practice. Let's do 12, 48, 1, 64, ... So give me the equation for that one. And then I want you to try your best on this one. You might not get it exactly, but I'm interested for you to try it. Let's do 10, 5, 2.5,
What do you want us to?
1.24. So I want you just to make the equation, the AN equals
What do
A1.
you want? And
No, I just want the equation. So just with ends, you just leave it as n. So give me the A1 and the R basically. What's up? What is the pattern? I know, I'm asking you now. You just have to look at the pattern. What do you, look at the numbers. How did you get from here to here to here to here?
That's a lot of work.
Well, you have to think about it.
Adding like 24.
You're adding 24, definitely not. Well, first off, you know it's geometric, right? Now, let's say, okay, if it's not simple math to you, this is something you could always do. Let's say here you have simple math, right? But it's not simple to you. What you can do is just divide the term after it versus the term before it. So 42 or 48, my bad, divided by 12.
4.
Which gives you 4.
no, it didn't work.
Did I mess up with this math? I might have messed up. What is 48 times 4?
48 times 12.
So if I was 4, but then it's.
Oh, it should be 194. I just did the math wrong. This should be 194.
What's 4?
So the pattern is 4. Times 4 though, okay?
Oh, it's one
I
ninety-two.
think
192. Okay. And then you can just do division to help you find the pattern. But you do need to recognize it's a geometric, because if you do division, but it's supposed to be adding or subtracting, you're gonna mess up. So you don't want to do that next time.
so. Am I doing,
Go ahead, Ben.
like you did AN equals, am I doing the AN one or like the A7?
No, just give me AN.
Oh, AN?
Well, AN equals blank. So what is it? What's the A1? We could, yeah, go ahead. 12 times 4 to the power of n minus 1. Good. Yeah. Let's look at the next set. 10, 5, 2.5, 1.25. So the pattern is divided by 2, but we need to show it as a multiplication. So how do you show divided by 2 as a multiplication? Times 0.5. I'm going to write it as this though. Times, you know it's divided by 2, so I'm going to times it by 1/2.
So that's the pattern?
The pattern is timesing by 1/2, because looking at the pattern normally, it should be clear it's divided by 2. But you can't use division here. You need to be a multiplication.
How did we get that? Oh.
And how do we get that? You could guarantee to get it. What you could guarantee to get it though, is again, the same thing here. 5 divided by 10 gives you 0.5. Yeah, okay.
I multiplied 52 divided by 10.
I know, but it's for the recording, for the future person who watches this. So then, let's do AN equals, we have our first term, which is just 10, pretty simple. Now our R has to be a multiplication, so we're gonna put 1/2. If you put 0.5, you still get it correct, don't worry about that. And then n minus 1, it's the same thing. Now, especially if you do it like this, where you do 10 divided by 5 divided by 10, like you're basically doing it backwards, you'll see at 0.5, so you don't have to like worry. If you put 0.5 in here, you still get the right answer. I'll just write it. Go ahead, person who has
So
question.
your final answer is just like for the top, AN equals A1. I meant AN equals 12 times 4 n minus 1, and then on the bottom is AN equals 10 times 1/2 times n minus, like that's your final answer.
Yeah.
Okay.
Yeah. Either one of these could be your final answer, because 1/2 and 0.5 is the same. Like if you use the calculator, 0.5 would be your thing. Let's do another interesting pattern. Everyone get me the AN formula. This one you'll do by yourself, and the second one is going to be the challenge one. Six over 5. 10 over 18. 54 over 20. 162 over 40. Dot, 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 dot. There's a challenge one, so try to think what you're doing. And here's another challenge one. Two, -4, 8, -16, 32.
Why are you giving us strategy? Yeah, isn't so.
I'm trying to let you think a little bit. What could you do to a fraction? Just look at it.
Divide.
You could divide.
Yeah, divide what?
That's a good question.
Bro, 6
What do we
divided
do?
by 5 is like point something.
Oh, divide 12.
So just write it down at least so. And then I just want to give everyone a minute. Try to think some solutions. Think about how you would find this. You're stuck on the test. You just got this problem. Mr. Tobin never taught you. You're trying to think. What the
Mr.
heck?
Tobin,
Six.
do not get us.
You did 6.
What about 6?
6.
What's 6?
I don't know. It's a guess.
It's just a random numbers. There's no reference to it.
It's a pattern.
What is the pattern? That's true. What is the pattern?
Mr. Tobal, do you hear me?
Yeah, I hear you. What's up?
Okay, so I know that like 5 times 2 on the bottom, I know that's the pattern, and I know on top it's times 3.
Oh, so Mariah got something really noticeable. She noticed on the top part of the fraction, it seems like you're multiplying by 3. And she noticed on the bottom of the fraction, what it seems like it's being multiplied by.
Yo, she's tripping us
Got
out.
it.
2. It starts with 5, but it multiplies by 2. So wait a second. How can I write something that multiplies the top by 3 and the bottom by 2?
3/2.
Both of you guys, good. Good job with the answer on that one. So the fraction, if you're doing 3 on top and 2 on bottom, that means your R for this one has to be 3/2.
What the heck?
So good job, Mariah. Good job, both of you.
6/5 times 3/2.
Say that one more time so I can copy it down. AN equals.
6/5
Uh-huh.
times 3/2, then exponent n minus 1.
And -1. Good.
Wait, so what? 10 was 3/2?
Yeah, 3/2. So when you have a fraction like that, look at the top and look at the bottom separately. Look at the top and then look at the bottom separately.
Well, we can do this first.
Look at the top and look at the bottom separately when you have a fraction, and you just multiply or divide the fraction correctly.
Oh, and then you can do 2. That.
Mhm.
That's what I was doing. And that's what I'm just copying.
Mr. Tobal, can
I
you
know.
explain-
I was saying yes to the top part. That's why.
I knew it, but I just.
Now the bottom, ask yourself what you got to do. Now I haven't got it. What will you have to do to the bottom to get that kind of pattern?
Mr. Tobal, can you explain to me why it's 6/5 times 3/2? Oh, never mind. You're following the formula.
My TI.
Yeah, just follow the formula. Initial value, your pattern. All right. Next one, we have 2, -4, 8, -16, +32. So what can we do to that? Why is it turning positive, negative, positive, negative? What is happening?
I don't have my TI before. This one doesn't have any negatives.
Should let you do negatives.
Stupid iPhone. Jeff Bezos. -4, the calculator. I advise you. It's -2.
This
-2.
A1
So -2 is your what?
over.
So here,
So it's 2 times -2.
They-
good. So the pattern is -2 because look at here. -4 times -2 becomes a +8. 8 times -2 becomes a -16.
AN equals.
16 times a -2, it will give you a +32
AN
equals,
2 times -2, and n not -1.
and -1. Make sure you put parentheses around the -2 because you want to indicate that that -2 part is being multiplied to the exponent. And Eliana, I heard you said the answer earlier. So you did.
What?
You said you were saying something about the answer, right?
Yeah, I'm gonna go
I
over
don't
it.
remember.
Okay, I think you got it, but I just want to make sure. Yeah. So different patterns require different numbers. If it's flipping negative, positive, that means your R is negative. If you have a fraction that's changing different values, the top and the bottom should be treated differently. Okay? And if you're dividing, you're technically multiplying by the decimal / fraction. All right? You guys want me to give you your homework early?
Sure.
All right. I'm gonna save this. Let me pull up the homework from here. We're not we're chapter 7. And I will do that tomorrow. What page is this? 454. I'm gonna write down here so I can keep track. Page 454, numbers. This is just telling me if it's a geometric. That's pretty easy, 3 to 11. And this is actually doing the math and then find A7. So I'll do 15 to 21. 3 through 11 odd. $15 to $21 odd. So I'll share the textbook page. Wait a second. What am I gonna do? Okay. So I'll share the textbook page. Three, 5, 7, 9, 11, 15, 17, 19, 21. So that's what you guys should be doing right now. I'm going to post on Google Classroom. As you do that. And I got to submit my attendance from today. Sure. A little bit better?
Wait, what's the homework? Like, which numbers were you doing?
3 through 11 odd and 15 to 21 odd.
15 to 21 odd?
Yeah. And who else? Post this in Google Classroom. So for the first set, you're just explaining geometric. And then if it is geometric, just tell me what the pattern is. If it's not geometric, just prove to me like what is causing it not to be geometric. Numbers 3 through 11.
Mr. Tobal,
Yeah.
for problem 3, I'm confused because it's always times 2, but 1 times 2 is 2.
Okay, so what does that indicate then?
That it's not.
Yeah, it's not. It's not consistent in this case. Let's check. Did anyone not have a book in class? Do you guys need me to post a photo with the homework every time? You do? All right, I'll make sure that. I'll stop recording because I'm not really teaching.